All right, I would like to welcome Margaret Heller, a digital services librarian at Loyola University, Chicago. She will be presenting her work on Against a Siloed Future, Open and Equitable Solutions in AI and Information Advocacy. Margaret Heller is digital services librarian at Loyola University Chicago Libraries, where she works on scholarly communication and open access publishing, emerging technology, and front-end web development. She is active in the library profession, currently serving as president of CORE, a division of the American Library Association. She is the author of the 2019 book, Community Technology Projects, Making Them Work, and also writes on issues surrounding privacy and copyright.
All right, thank you so much. I'm really honored to be here. It's, I think following that talk, I think will be useful because I can talk about my context, kind of working as in the library world and working with open access publishing. And I'm going to talk a lot about licensing of library data. So copyright is a big piece of that. And I spend a lot of time working on copyright issues. But a lot of times what we spend when in libraries, we spend working our time with items that we do not hold the copyright for, that we license. So I'm going to give a little bit of library context for the people who that's new for. And then we can talk about AI and libraries. So I want to start by separating this question of AI and what problems AI should solve for libraries and research into two categories. So there's the materials that libraries collect, describe, and preserve, and the services around these tasks. The other side of things is how the users of the material access and interpret that material. So there's going to be limits on both sides based on copyright, data ethics, and licensing to what we can actually do, and what I think we should do. So I'll start with the first item. So I think that the utility of current AI technology as such, using current standards of machine learning and computer vision, it's already in use in various formats. And I think we just saw an example of how large data sets can be used to create new input and understand things like copyright infringement. So there's a lot of promise there for library work. However, I want to point to the fact that as we've already heard this morning, there are ethical problems inherent in any algorithm that we use. So if we're doing descriptive work of a historic image, you can imagine that algorithms based in centuries of systemic oppression and prejudice would perhaps continue those systems. So when we work with underrepresented communities in description, we have to be very careful in what kinds of descriptive language we're using. However, these can be really used as a tool to aid expert catalogers or describers and deal with backlogs of digitized items and improve accessibility. I'll share an example later, but if you can imagine, if you have hundreds of thousands of digitized objects representing what have been in print, having a machine work on those is going to make sure that we actually can access those. So digitization certainly has its own copyright issues, as the ongoing litigation with Internet Archive has illustrated. But when we have digitized images, digitized items, we can get assistance in creating metadata for those items and then making them more accessible, and then finding, again, those potential rights violations. So I'll talk a little later about some ways that this is actually manifesting in library work, but I want to talk now about the second category, in which users access and interpret materials in library collections. So as I mentioned, libraries own relatively little of our own digital content outright. And we have little control over the description and access experience for users in most cases. So I'm going to talk about how we actually got here and why our current situation worries me when it comes to consumer-facing generative AI tools that purport to provide information. But I'm also excited about the future, and I hope that we can take this inflection point as a way to move to an open future by breaking down some of the silos that exist. So I'm going to go back in history a little bit to explain the scale and the context for library data, and then help you understand why we are where we are today. So I'm going to start with early computerization of libraries. So this really actually was libraries began to be automated largely because of military reasons. So there was prior to computerization, there were punched card systems that could be used sort of in various manual sorting ways to determine literature that was relevant to a topic. But when there was a need for large scale access to research and surfacing important scientific papers in World War II, it became apparent that these current systems were not sufficient, that they needed to automate retrieval of scientific information, scientific literature. And in addition, the huge jump in college enrollment in the 1960s led to massive construction projects and actually much larger library collections that made automating necessary to work at that scale. So our brutalist library buildings full of books are a legacy of that. And in some cases, these automation systems had to be designed because to actually move the books around and understand where they were to computerization that had never been necessary before. So that's kind of comes out of this Cold War, post-World War II legacy of funding. So that's kind of, those were the initial motivations in automating scientific literature. Early indexing of library literature consisted of a number of different files that were available usually on a mainframe, and they can required constructing a query, waiting for your shared time on that mainframe, and then retrieving documents. So it was a very lengthy process and required a good deal of understanding of the indexing of the system. Later on, that turned into the system of a data bank. So a data bank is a system that combines sets across files and presents one set of results from multiple databases. So an example of this was Dialog, which was a search language that started out of experiments at Lockheed, again, that military background, in the early 1970s, and later grew into software and a commercial service that helped address these problems. So the expert searcher still had to know the specialties about each file, but with experience could create comprehensive sets of citations across these multiple files. And then online search services, when they became available, while they were potentially very expensive, allowed for more real-time access to current information. And interestingly enough, you'll see an example that this sort of concept of real-time versus snapshot has returned a little bit when we have come to machine learning. So, and that online is not the sense of how we use it now on the web. So when the actual at this point, it was more just you had real-time access to that, as opposed to being able to dial in remotely. And then eventually, in the late 80s and early 90s, there was also the notion of a CD-ROM, that a user could access a CD-ROM to access these indexes, or access local files that are loaded on a mainframe that they could access from a terminal. So this is sort of where we were in the pre-web era. Of course, when the World Wide Web became mainstream, library database providers were very quick to replace some of these services. So these all still exist. You can still access Dialog to this day. So the internet provided the ability to provide access to more indexing, but also the full text of articles. So of course that was limited early on. And to be clear, this indexing was certainly represented a good deal of labor to create these, understand articles, arrange them, describe them in a way that made them useful to users. But there was never this idea before that you would necessarily be able to access the full text to help you understand whether a particular item was of use to you. You would use the indexing to the best of your ability to understand if it was going to be used to you, and then you would have to actually access the material. We didn't expect to have the full text indexing to tell us whether the item was of use. So by the 2010s, the move was to something what's called web scale discovery at the time, that would combine multiple different databases along with all the other types of content that libraries have, including locally digitized collections. So the Loyola Library uses one such discovery layer. Any of you would probably your library uses something similar. And it's the discovery layer is called because it provides uniform access to what under the surface is a complex set of local and cloud indexes, some of which is handled locally, some of which is handled by the library community, and some of which is provided by the vendors. Now it's meant to be invisible to the user where the indexing is coming from, where the data is coming from, where the access is coming from. It's supposed to provide this one uniform experience. The index we have access to contains some 3 billion records. So it's quite a large number, but that number elides several facts that are important to understanding our current inflection point. So this indexing, like I mentioned, it's labor, it costs money to do this. It makes sense that it's a service to purchase. However, having this access to these 3 billion records in all these indexes, most of these indexes require a subscription to search, much less full text, which definitely requires a subscription. There's very little good indexing available for free, which makes sense in some ways, but that means that the actual user in each catalog doesn't have access to the full number of possible records. And some major database providers do not provide indexing for any of their databases to our discovery layer, and there may be the similar cases for other discovery layers. There is a corporate standoff that's making that unlikely to ever actually happen. So there's some overlap in indexing, but we cannot search for all our subscribed library content in one place, no matter what the promises made are. And then the other question is, what is the value of 3 billion records when the ranking algorithm is a black box, which it is in this case? I think we've already heard this morning about difficulties with algorithms, but even in discovery layers, there's been work building on Sophia Noble's work to find troubling rankings in discovery layers as well. So what we discover is if we could sort of say we could always find the best papers on any topic in our current system and be sure how it was doing it, that would be one thing. But adding an additional black box of artificial intelligence on top of this, it would be even more difficult to be sure that biases were no longer present. The last factor I want to bring up before we move into the current inflection point is the massive provider consolidation that has taken place over the last 5 years in particular, though it's certainly the last couple decades. There used to be hundreds of companies providing indexing and library services that are now represented by less than 10. So this shot here is just one of multiple maps of mergers and acquisitions you can find on this mergers and acquisitions page. And it's what this has resulted in is these corporate standoffs that are only getting worse because there's so little movement in the marketplace. Libraries are kind of locked into only a very few providers for services, and libraries have limited access to data in other data in other formats due to licensing restrictions and various other factors. So I'm going to get into that right now. Okay, so I mentioned AI for description and preservation, and I want to highlight this because I think there's a lot. This is where things are already happening and where there's already lessons to be learned. So I want to start with this. So this idea of computer vision and being able to understand, use computers to help us process visual content. So one example is this tool called AMP, developed by partners from Indiana University Libraries, AVP, University of Texas at Austin, and New York Public Library. This is still in a proof of concept stage, but I saw it recently at a conference, and it's really almost there, and it has a lot of promise. So Emily Linema from Indiana University recently described this tool is that the vision of AMP is to allow archivists and librarians to create workflows leveraging artificial intelligence and machine learning services to help generate metadata supporting identification, discovery, and rights determination for these collections. These workflows include tools that perform tasks such as speech to text, named entity recognition, applause detection, and facial recognition. So this project combines a number of open source and commercial software libraries for all of those different aspects, and it's testing kind of which works but the idea is that you can create a workflow combining tools that you license and open source tools to create a workflow to help you take this is hundreds of thousands of items that they're talking about backlogged video, and often which describe marginalized communities. And so they have a need to process this and make it available, but make it usable and accessible as well. So this is a really, kind of exciting moment where we have these, backlogs of content that we can actually handle now, but again, with that expert available. And then there's other aspects, other tools that we've even have access to right now that help with other services such as automated preservation of file formats. As you can imagine, file formats change. We have, in order to preserve them, we need to make sure that we are migrating them over time. So I now want to move into the concept of AI for user access and interpretation. We are kind of right at a moment where this feels like it's changing. And so I think there's a lot to be thought about right now about this current moment. So I want to start with ethics. In a 2021 chapter in a book on machine learning for libraries, Boyun Kim, who is a philosopher turned librarian, outlines the moral problems of AI and its potential use in libraries. So these are somewhat generalizable across many information realms, but I want to spend a little time thinking through these as we look to the technical and copyright issues. What problems of user access and interpretation would we like to see AI solve, and how could we avoid these ethical problems as we do so? So the idea of intellectual isolation and, sometimes called the filter bubble, is one I think we're well aware of. But this idea of weakening of cognitive agency and autonomy, I think is very interesting when we look at this, because one issue that I'm sure we're all aware of, the vast number of articles published every year. So we might be able to keep up with a small slice in our specialty areas, but what are we missing? At the same time, if we're presented with, here are the articles you need to read on this topic, we might not know what we are missing. We might not understand from that side as well. So the systems that we use right now that rely, for instance, on citation ranking tend to reinforce existing structures. It would be better if a computer could somehow figure out the best articles to look at from new scholars in obscure journals, from scholars working in the global south, from other kinds of journals that we know may not get much indexing notice, but may be valuable to the scientific literature. This could be a useful way to address current ethical challenges in the system. But I think we are a long way to making that happen, because we do not know yet how these algorithm flaws may continue to perpetuate harm. Okay, so moving into this, I'm going to have we'll have the humorous portion of the presentation, where we spend a little time on these AI chatbot hallucinations, which I know we all love. Okay. So starting here, I asked ChatGPT a few weeks ago, can you give me citations for 5 good articles about community technology projects in libraries? So that's obviously a topic I know a lot about. And so this is what it was returned. And I mostly did this as just to, for the laughs, because I knew it was probably not going to be useful. But what I thought was, it has that first article is a real article. It's not really related to the topic, but it sort of is. But the next 2 through 5 are all completely fake articles. They sound like they could be real, but they're not. They're not real at all. If you click on those DOIs, they take you to completely different articles. So when Bard, the Google generative chatbot, first became available, I asked that same question, and it told me at that time it wasn't programmed to do that. And I thought, well, that's at least an honest answer. But I just asked again this week, saying, hey, maybe they've made a program to do it now. And now I got this result. So I thought, oh, this looks promising, because there looks like there's some citations and some context for what this is. And then I looked more closely at it, and I looked at the first one, and I said, wait a second, I know what that is. That is a review of the book that I wrote on this topic. So somehow the algorithm has somehow combined the reviewer's first name with my last name. And the summary of the book or of the article is actually what the reviewer said about the book that I wrote. So I thought, this is still not quite right either. So this doesn't really surprise me in a lot of ways because I knew there's very limited access to citation data. So I'm going to explain a little bit about where that data is. So this citation data has really not available on the open web in a way that is actually useful. So for a long time, Microsoft, with the Microsoft Academic Graph, was, I think, quietly powering much of the citation infrastructure on the open web in ways that I don't think a lot of people realized. So it used relationships between academic literature to create citation relationships and map out academic relationships, journals, conferences, that kind of thing. And this was used in Microsoft services such as Bing and Word, but it also powered a lot of other services that were able to draw on the citation data in different ways. Now, this was sunset in December of 2021. And so we no longer have access to the current version of this data. And I looked at the way that they described this back, right before it was sunset. And I now see similar language being used to describe how GPT-4 is going to power Bing and Word and all these things. So it seems that they've sort of moved from this idea of we're going to create this graph of what is available in scholarly literature to this idea of we're going to have AI explain all these things to us. Now, Google Scholar, we probably all are very familiar with using their citation data, and it's plugging along more or less unchanged from when it launched in 2004. In 2014, an interview with Nature, the co-founder of Google Scholar, Anurag Acharya, described the reason he couldn't build an API is because our indexing arrangements with publishers preclude it. We are not allowed to scan the articles, we are allowed to scan the articles, but not to distribute this information to others in bulk. And he didn't want to harm the relationship they have with publishers by providing an API to the data. And that is still the answer to this day. And funnily enough, he also, back in 2014, explained some of the problems we have with trying to use users to train models about relevancy. They've tried to make a recommendations engine, but there is an inherent problem in giving you information you weren't actively searching for. It has to be relevant, but not too relevant because you already know those articles. I don't think getting our users to train a recommendations model will work. That is too much effort. And I think that we are finding that is still probably the case this many years later. So I want to now talk about Open Alex, which I'm very excited about. So this is a new product that launched in January 2022, right on the heels of the Microsoft loss of the Microsoft Academic Graph. And it kind of seems like it could be the successor. What's the great thing about this is it's free and open source, so it has a premium tier, but it releases all of its content with a CC0 public domain license. And this is actually doing what is required to share this citation data at scale and be able to use it in useful ways that could be used in machine learning and generative AI. I want to talk about then, and moving on from citation data and trying to surface different types of papers is, I want to talk about the full text of the article. So it doesn't really tell you much about, if something is cited, it doesn't really tell you much about the content of the article. So we can imagine that using all the text in the articles to do topic modeling and create data sets for large language models might be the way forward. So that makes it, okay, well, we'll just figure out, we'll scan all of scientific literature and train models on that. I will say this might make the ChatGPT feature to write in a certain person's style so much better that no one has to write a new paper ever again. You just keep plugging away in your own style. But assuming that if we could surface important connections between researchers and ideas at scale, I want to consider who actually has the data and their motivations for connecting those data sets. So I listed here just 3 tools to which libraries can subscribe to make access to the content to which they already subscribe available for text and data mining. I will point out Elsevier doesn't charge anything extra, but it's already so expensive. Many libraries can't access it already. And in a way, I don't blame companies for asking for support to build out these new services. But then given these silos, these vendor silos, these content silos about indexing and content, I question how much of this we can build any sort of funnel between these silos to make a complete picture. We're always going to be building in between these different silos. So I think right now, given the lack of investment in maintaining academic graphs and the lack of ability to license full text content across providers, I don't see that at this point any one model could be holistic. So there's different ways that this is being dealt with. And companies are popping up to create recommendation engines based on some amount of topic modeling to what is available to you in, for instance, a discovery layer. So that, you know, however much percentage of that 3 billion records you have access to. And what I see is probably happening in terms of that full text modeling, I could see that if a vendor has access to a full text indexing, they could license some of these, like, for instance, the GPT-4 algorithm to to work with that data set. I don't think that, I don't know when that's happening. It's not immediately, but I can see that's probably in the future, because already I think students have really shifted the way they search to natural language. They're not typing in one word, they're typing in a very complex question sometimes. And our interfaces have already tried to adapt to that way of that mode of natural language searching. And so I think this idea of moving into this idea where it feels like a back and forth with a librarian through a chatbot feels like a way that we will be naturally going. However, I think without clear attribution and clear understanding of these algorithms, I think we should be skeptical of what these large language models return. And we should wonder if the whole story is being told in those interactions. So at this inflection point, I think that some problems in providing access will be solved with description at scale. So if we have our, millions of items that lack item level description, we can now get more access to those and be able to use them in different ways. Right now, I think that some problems cannot be solved without open data. So understanding the whole picture of academic work, as long as things are kept in these different silos, we will not be able to solve comprehensive access to all of scientific literature. But I think that I'm hopeful for a future that helps us solve this last point, that some problems should not be solved. So we should be able to see ideas and researchers and connections that we never knew could exist and no one individual person could know existed. But without the expertise to know what we didn't know, that we didn't know already know this, I don't think we'll be able to use these tools without worrying we are living in a citation hallucination. So thank you very much.